Hello, good morning. My name is Gopong Sankitiakon. So today we are going to talk about Spring Security, Servlet application. So this is my agenda. So we have architecture, value of filters, delegating filter proxy, filter chain proxy, security filter chain, and security filters. So let's get started for the first one, the architecture. So in this session, we discuss Spring Security high-level architecture within servlet-based applications. So we build on this high-level understanding within the authentication, authorization, and protection agent exploit section of the reference. So next, a review of filters. Spring Security Servlet support is based on servlet filters. So it is helpful to look at the role of filters generally first. The following image shows the typical layering of the handler for single HTTP request. The client sends a request to the application, and the container creates a filter chain which contains the filter instances and servlet that choose process the HTTP servlet request based on the part of the request URI. In a Spring MVC application, the servlet is an instance of dispatcher servlet. At most, one servlet can handle a single HTTP servlet request and response. However, more than one filter can be used too. So the filter can be used to prevent downstream filter instances on the servlet from being invoked. In this case, the filter typically write in the HTTP servlet response and modify the servlet request and response used by the downstream filter instances and the servlet. This is the filter chain usage example code. So you can see we have the process before and after the chain. So since filter impacts only downstream filter instances and the servlet, in order in which each filter is invoked is extremely important. So delegating filter proxy. Spring provides a filter implementation named delegating filter proxy that allows bridging between the servlet containers lifecycle and Spring's application context. The servlet container allows registering filter instances by using its own standards, but it is not aware of Spring-defined beats. You can register delegating filter proxy through the standard servlet container mechanism, but delegate all the work to a Spring beat that implements filter. Here is the picture of how delegating filter proxy fits into the filter instances and the filter chain. So delegating filter proxy look up bean filter O from the application context and then invokes bean filter O. So the following listing shows pseudocode of the delegating proxy. So as you can see, the first line of code is to lazily get filter that was registered as a Spring Bean. For example, in delegating filter proxy, delegate is an instance of bean filter O. And the second line of code is to delegate the work to the Spring Bean. Another benefit of delegating filter proxy is that it allows delaying lookup filter bean instances. This is important because the container needs to register the filter instances before the container can start up. However, Spring typically uses a context loader listener to load the Spring Bean, which is not done until after the filter instances need to be registered. So next is filter chain proxy. Spring Security's servlet support is contained within filter chain proxy, and the proxy is a special filter provided by Spring Security that allows delegating to many filter instances to security filter chain. Since filter chain proxy is a bean, it is typically wrapped in a dedicating filter proxy. So this is the image show the law of the filter chain proxy. As you can see, the filter chain proxy is wrapped by dedicating filter proxy. And next is security filter chain. The security filter chain is used by filter chain proxy to determine which Spring security filter instances should be invoked for the current request. The following image shows the law of security filter chain. So the security filters in security filter chain are typically bean, so they are registered with filter chain proxy instead of delegating filter proxy. Filter chain proxy provides a number of advantages to registering directly with the servlet container or delegating filter proxy. First, it, it provides a starting point for all Spring Security Servlet support. For that reason, if you try to troubleshoot Spring Security Servlet support, adding a debug point in filter chain proxy is a great place to start. So second, since filter chain proxy is central to Spring Security usage, it can perform tasks and are not viewed as optional. For example, it clears out the security context to avoid memory leaks and also apply Spring Security HTTP firewall to protect application against certain types of attacks. In addition, it provides more flexibility in determining when a security filter chain should be invoked. In a servlet container, filter instances are invoked based on the URL alone. However, filter chain proxy can determine invocation based upon anything in the HTTP servlet request by using the request matcher interface. So this is the image show multiple security filter chain instances. So in the picture, so the filter chain proxy decides which security filter chain should be used. Only the first security filter chain that matches is invoked if a URL of /API/messages/ is requested. It first matches on the security filter chain or pattern of /API/star. So only security filter chain O is invoked, even though it also matches on security filter chain N. If a URL of /messages/ is requested, it does not match on the security filter chain or pattern of /API/star. So filter chain proxy continues trying each security filter chain, assuming that no other security filter chain instances match. Security filter chain N is invoked. Notice that security filter chain O has only 3 security filters instances config. However, security filter chain N has 4 security filter instances config. It is important to note that each security filter chain can be unique and can be configured in isolation. In fact, a security filter chain might have 0 security filter instances if the application wants Spring Security to ignore certain requests. So, next is security filters. The security filters are inserted into the filter chain proxy with the security filter chain API. So, those filters can be used for a number of different purposes, like exploit protection, authentication, authorization, and more. The filters are executed in specific order to guarantee that they are invoked. at the right time. For example, the filter that performs authentication should be invoked before the filter that performs authorization. So it is typically not necessary to know the ordering of Spring security filter. However, there are times that it is beneficial to know the ordering. If you want to know them, you can check the filter order registration object code. So these security filters are most often declared using HTTP security instance. So to exemplify the above paragraph, let's consider the following security configuration. So as you can see in the code, we use annotation of configuration and enable web security to use the security filter chain. So we define the annotation bean and with the object of security filter chain. So as you can see, we use the variable HTTP as the HTTP security object, and then we add the filter. So in this code, we add the first is CSRF filter, and then we have a HTTP basic, or it is the username password authentication filter. Then we use form login or the form for the field username and password. And the last one is authorization filter. So that is all for the presentation of the Spring security in the Servlet application. Thank you for your attention.